All right, functions, we are starting a new unit finally. All right, we are doing an introduction to trig. This is just very introductory. It won't be that bad, trust me. So just so you know, going forward, we are going to take the unit 7, that's what we're on right now. So we'll take that assessment in a couple of weeks. Then we'll start unit 8. Then we will take the second assessment for the unit that we're in right now. Then we'll take the second assessment for the unit that we will be in a couple weeks, and then we have a final. So that's it. You guys have 5 more assessments, and then we're done. So go ahead and hit pause, and really the only thing you need to write in your notes is that the nth root of a times the nth root of b is going to equal the nth root of a times b. So just put that in your notes because we're going to use that idea to undo and redo and all that stuff. So here are our first examples. So that would be the square root of 65. And then if we were to do it this way, we would get the square root of 7 times xy. So this is going to work for cubed roots, 6th roots, 5th roots. So we're going to end up with the cube root of 14. And then we end up with, so we're going to make sure those rules of exponents don't disappear. So when we do r squared times r cubed, we end up with r to the 5th. And the same is true here. And then D, make sure you know that you can only do this when our indexes are equal. The conditions for a simplified radical. So now we're going to start simplifying some stuff. So the radicand, the thing underneath the radical, has no factor raised to a power greater than or equal to the index. So we always want to write them in terms of powers. We could write them out individually. It doesn't really matter. The radicand has no fractions. And the denominator does not contain a radical, and exponents in the radicand and the index of the radical have no common factors except for 1. So that is something that we will be doing going forward. Okay, so that would look like this. So the square root of 32, we're going to simplify that, and that means what we're going to do is we're going to look at 32 and see if we can divide 32 by any perfect squares. So the way that I look at it is I'll look up on my wall and I'll be like, oh, 36 is not going to work, it's too big. But 25, nope, that's not going to work. It doesn't end in a 0 or a 5, but 16 might. And 32 divided by 16 is 2, so we could rewrite that as the square root of 16 times 2. So 32 is equivalent to 16 times 2. But we just said that if we break those up and we rewrite them as the square root of 16 times the square root of 2, we can do that. That this is the same thing as this, which is the same thing as this, but I know what the square root of 16 is. The square root of 16 is 4. I don't know what the square root of 2 is. It's down to its it's a prime number, so I can't rewrite 2. It would be 2 to the first power would be the power that 2 would be, and that is smaller than the square root, and they don't have a common factor other than 1. So I'm going to do the same thing again with the square root of 300. Well, if I look up on my wall, I could probably divide by 100. So, square root of 100 times 3. That is probably the biggest perfect square I could divide by. And then I'm going to end up with the square root of 100 times the square root of 3. And the square root of 100 is 10, so I'm going to get 10 times the square root of 3. And then we're going to try the same thing with 35. So I can't divide 35 by 25 evenly. 16 does not go into 35 evenly, 9 does not go in, and 4 does not go in. So I'm down to 1, so that can't be simplified any further. All right. Now let's do cubes. So now we have to not think of perfect squares, we're going to think of perfect cubes. So a perfect cube, I'm at 54, 64 is not going to work, let's try 27. 27 works. So we end up with the cube root of 27 times 2. Well, I know what the cube root of 27 is. The cube root of 27 is 3, and the cube root of 2 is just the cube root of 2. So we end up with 3 times the cube root of 2. Now, I can't think of a number that would go into 243 as a 4th power. Let me think. So actually 81. 81. So 3 to the 4th power, 81. Would go into 243, right? So 3 to the 4th power, which would be 81. And then we just end up with the 4th root of 3 to the 4th where the fourth root of 81 is 3 times the fourth root of 3. All right, so I think that, oh yes, sorry. So go ahead and get that down. All right, so then our next examples are, now we're going to do some with variables. So we want to think of perfect squares. So p to the 7th actually has three perfect squares. No, two perfect squares. P to the 3rd power. So we're going to rewrite that as 5 to the 2nd power, because we can just undo that, or we could think of it as the square root of 25. And then p to the 3rd power to the 2nd. So p to the 3rd times, or squared, is p to the 6th, and then we need one more p. So then we can take the square root of everything, so we end up with 5 p to the 3rd. That goes on the outside, and the only thing that's left is that square root of p. We can do the same thing with b, so 36 is the largest square that could go into 72. I can rewrite y cubed as y squared times y. That's a perfect square. And then what's left is x and then y. So then we take the square root of 36, the square root of y squared, which is 6y, and then we're left with 2yx underneath. Now we got to think of perfect cubes. So when we rewrite this one, we're going to be thinking of perfect cubes. So we got negative 3 cubed, y to the 6 times y. So y to the 6 times y is y to the 7th, y to the 3rd, x to the 3rd, x to the 2nd. So that's a perfect cube, and that's what's left over. And so we end up with negative 3 y squared x z squared, and times the cube root of y x squared. Right? And then d, we're going to do the same thing. That negative is going to stay out front, but we are going to think of a fourth root. So we could rewrite this as 2 to the 4th, because we said 16 times 2, right? So we could do 2 to the 4th, which is 16. And then we could rewrite a to the 4th times a, and then b to the 4th times b to the 3rd. So we've got 2 to the 4th right here times this 2, because that would be 16 times 2. We have a to the 4th, that's written as a 4th power, and then a, and then b to the 4th power, that's a perfect 4th power, and then whatever's left from the b to the 7th would be b to the 3rd, and then we're going to take out all of our perfect fourths, and we end up with negative, don't forget the negative that was out front, so negative 2ab, fourth root of 2ab cubed, because that's what's left over. All right, if you have any questions, please come to class with that. We will be moving on tomorrow, which is Wednesday, and we will start some more stuff. All right, have a great day.